Good morning, USRNs. Today we will talk about ABG interpretation. Now, the very first step that we should do is to memorize its values to determine whether or not they are acidosis or if they are alkalosis. For pH level, the normal value is 7.35 to 7.45. For carbon dioxide, just drop the 7 from pH. It's going to be 35 to 45. For bicarbonate, that's going to be 22 to 26. So basically, you are so familiar, or I myself is so familiar with pH normal value. So my concern here right now is just the bicarbonate, which is 22 to 26. Because for CO2, I'm just going to drop the 7 from the normal value of pH. That will leave to 35 to 45. Now for pH, if it's less than 7.35, that could be acidosis. If it's more than 7.45, that's gonna be alkalosis. Now let's go to bicarbonate first, because it has the same logic. If it's less than 22, that's going to be acidosis. If it's more than 26, that's going to be alkalosis. Now the only difference is the carbon dioxide, the one in the middle, if it's more than 45, it's gonna be acidosis. If it's less than the normal value, which is 35, that's going to be alkalosis. Now we have a technique that we call ROME, R-O-M-E, like the country. It stands for respiratory, opposite, metabolic, equal. So if it's respiratory, for example, if the carbon dioxide and the pH level has an opposite value, in that example, we have an increase in CO2 and decrease in pH. That will be respiratory acidosis. Respiratory because they are opposite, and acidosis because the pH value drops. And for example, if it's CO2 which is dropped and increase in pH, that will be respiratory alkalosis. Respiratory because they are opposite, and alkalosis because the pH is above the normal value. If it's metabolic, we have to look at bicarbs and pH here. So let's say if bicarbonate is decreased and pH is decreased, it means that they are equal. That will be metabolic acidosis. Metabolic because they are equal, and acidosis because the pH value drops. Another example is when HCO3 is up and pH is up. Since they are equally up, both of them, that will be metabolic. Alkalosis because the pH is higher than the normal value. So that's going to be metabolic alkalosis. Now another technique that we should know is on how to determine if it's like compensated or uncompensated. And if it's compensated, if it's going to be partially or fully compensated. Now for uncompensated, you need to look at carbon dioxide and HCO3. If either one of them is in range, it's gonna be uncompensated. Now for partially compensated, you're still gonna look at CO2 and HCO3. This is opposite of uncompensated, and if both of them are out of range, it's gonna be partially compensated. Now for fully compensated, you just have to look at the pH. If it's within the normal range, it's going to be fully compensated. Now there is this time when we see a question in an exam that doesn't say any value of any of those three above. We could just distinguish of whether or not they are metabolic or respiratory, and to find out if they are either acidosis or alkalosis. Now for metabolic acidosis, we have some examples right there. We have diarrhea, DKA, renal failure, shock, and starvation. Those are the examples of metabolic acidosis, and the signs and symptoms would be dysrhythmias, fatigue, headache, cosmos respiration, shortness of breath, and weakness. For metabolic alkalosis, examples are hypokalemia, suctioning, TPN, when the patient is taking Tums, and also vomiting. The signs and symptoms would be decrease in respiratory rate, dizziness, and numbness. On the other hand, we have respiratory acidosis, examples of which are coma, COPD, hypoventilation, respiratory failure, and sedatives. For the signs and symptoms of respiratory acidosis, we have anxiety, blurry vision, confusion, headache, and restlessness. For respiratory alkalosis, we have examples like anxiety attacks, blood transfusion, hyperventilation, increase in altitude. The signs and symptoms would be dizziness. Just like metabolic alkalosis, we also have dry mouth or xerostomia and numbness, just like metabolic alkalosis.